I got our schedule here, yeah. Okay, so I got our schedule here. So we should finish chapter 5 Monday. Our next test is 4 and 5, right? See, it's easier if you just open this latch in front. Yep, just open this whole gray thing. Yep, pull that down pretty hard. There you go, and then you can see the junction. Just pull that out a little bit. There you go. Is there any open tracks in there?
Yeah, there is.
Yep.
Thank you.
Yep. So here's our schedule. We did 4-4 to 4-6 last class. I'll review that because it's tough. 5-1 to 5-3 today. 5-4 to 5-4 through 6 on Monday, and then we're starting trig. But I'm going to give a quiz on that Wednesday. Okay, that Wednesday is what is today? The 19th. So that's the 26th. The Monday before the test, we'll just review. Okay, I'll give you a mock test again, just to practice, right? And then we'll take our test, and then we should be able to finish all the trig in November. Test at the end of November for our last test. Review for an entire week, which is only 2 classes before the final exam. So next Wednesday, a quiz. And I'll give you more detail on that Monday. Most likely, it's like the 2 problems I do today as a review, and the new problem, 2 of the new problems I do today in chapter 5. So I also have up there homework. So I've suggested homework in 4-1 all the way up to 5-3. 4-3 we don't do. That's complex zeros. Okay. The ones I want you to hand in are on the right. The ones that I think you should do anyway are in the middle. Those right suggested problems where you can do them on you could write on a window with a whiteboard marker or on a bar napkin. I don't care, right? But the other ones I want you to turn in, and then they should be perfect, right? I am thinking that November for Thanksgiving, that Monday for Thanksgiving week, I probably won't be here. But I'm not going to get you a sub. I'm not going to make you come that week either. So I've decided I'm creating, instead of a spring break, a fall break. But I'll get back to you with more details on that, right? Good. So homework questions for me, anything you want me to do? So I want to start every class. You should be emailing me questions to solve for you or look over for you. Yes? If you don't have questions, it means you're not doing enough work. If you don't have questions, you're not doing enough work. Or you're a genius and you shouldn't be in the class. Right? So you got to be getting me questions. Okay? You got to be practicing. Right? You're doing odd problems. You do one problem, you look at the answer. If you get it right, good for you. Move on. You do the next problem, look at the answer. If you get it wrong, hey, all right, try it again. Try and use the answer to give you a hint at where you're supposed to go, right? Keep going, rinse and repeat. If you're stuck on a problem and you've tried it a couple of times, you need help. Don't waste your time. It doesn't mean you should stop doing homework. It means maybe move to the next section, right? And you'll see the problems are grouped in sections. Right? So if you've tried 1 or 2 in that section and failed, you need help in that section. So go to the next one though, right? So you can send me via email. You can come to office hours. I was here in this room. I've been in this room since 8:30 this morning. I have 2 other classes, but from 12:30 to 2, I'm in here just for you. Okay? So you can come in early and get help. If we leave early, and you don't need me, then I'm saying, hey, hang out here until the class is actually over and work on the board. Work with each other. Get a study group. You can also go to the Math Learning Center. There's also math tutoring online. You know, and of course, you could solve any problem you want with some of the web apps like Photomath. Take a photo of it, it'll give you the answer. But you got to make sure you're practicing, right? So questions about the schedule, questions about homework. It's a lot of homework, 1, 2, 3, 4, 5, 6, 7, 8, but I'm not collecting it until the Monday, 10/31, October 31st, right? So don't put it off. Get to work on it, yes? Yep. Yes, second is, yeah, exactly, suggested. I don't care how you do it, like, you know, you're having wings and a couple of beers with friends and you got a problem on a napkin, that's fine. I don't need to see it, but you need to, right? And these are the ones I want you to turn in, right? October 31st, and I'm probably going to add 2 or 3 more. So start working on it, chip away at it. Make sure you're telling me what section and what problem number it is on each page. Yeah. Quit not today. Quiz next Wednesday. Most likely on 4, 4, 4, 5, 4, 6, 5, 1, 5, 2. I will get that down to more details on Monday. Okay, but the 2 main problems I do today from Monday and the 2 main problems I teach you today. That's what I'm thinking the next quiz is, okay? And again, I'm trying to help your grades a little bit by, you know, I think you did better on that. Oh, I didn't grade the last quiz, did I? Sorry, I'll do that. I gave you solutions, right? No, I went through it when we did our review, yeah. So anyway, cool. Let's recap. Unless you have questions for me, anything you want me to do from the book, from an old quiz, from a lecture? Yes. Okay. I do. Purple. Okay. For you, forever. Keep it. So let me recap a couple of things, right? Let me recap 4.2. I've got a particular function, y equals 2x to the 5th minus x to the 4th minus 4x cubed plus 2x squared plus 2x minus 1, and I want you to factor it, right? So how many factors could I possibly have? What's the maximum number of factors I could have? 5, right? I have 5 possible roots, which would give me 5 possible factors with multiplicities, right? And I want to try and get things whittled down to where I have real factors and possibly a non-reducible quadratic, right? Does that make sense? One final ax squared plus bx plus c, right? That might give me complex zeros or might give me irrational zeros. I'm going to try and give you one just like this on the quiz and on the test. So, but we're challenging your synthetic division here. So let's put this one in Desmos first. The Calc 1 classes are out on this schedule. All of the names aren't in there yet. I am teaching 2 Calc 1 classes. But again, you're picking a class, you know, either based on your work schedule or et cetera. If you're not an early riser, you're not taking my 8 a.m. Calc class, right? You'll take anyone else's class that starts at 12 or later, right? What's that? Spring. Yep. So f of x equals, did someone write that down? I got it, 2x to the 5th. minus x to the fourth minus 4x cubed plus 2x squared plus 2x minus 1. So here it is. Notice what I have. What's the mother function here? Two x to the fifth, right? The 2 is just giving me that stretch in this direction, right? So it's an odd function. I know it starts low, ends high, right? We okay with this? Remember, you have a formula sheet. That thing should be packed with every bit of information I've ever given to you, or the book gives you, right? The book just says it in a super nerd way, right? So just, how many zeros do you see? 3, nice. You see any multiplicities? Two multiplicities of 2. So 2 multiplicities of 2 and 1 other 0, there's all 5 of my zeros, right? So any particular 0 you like? The 1. I like to hit, if I can use a positive to do synthetic, I'll do that, right? So I'm going to start to synthetic divide with a root of 1. Everybody with me? So we want to factor this, right? So we're going to start, we can see, right? We see from the graph y has a 0 of 1 with a multiplicity of 2. Does everyone agree with that? How do I know there's a multiplicity of 2 there? Because of that bouncing, right? When it's an even multiplicity, it won't go through the axis. It'll hit the axis and stay on the same side, right? So, and I know it's 2 because there's another one bounces and there's another root, and I can only have 5, right? So we're gonna find that first factor, right, by synthetic with 1. So I need a 2, a minus 1, a minus 4, a 2, a 2, and a minus 1. No placeholders in this one, but a lot of times there will be. Make sure you practice a bunch of those, right? So how do I start? I bring down that initial coefficient, yes? And I multiply and add. 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 I better get a remainder of what? 0. If I get a remainder of 0, I know 1 is a 0, right? So since the remainder is 0, x equals 1 is a 0, and x minus 1 is what? A factor. So is, 2x cubed sorry, 2x to the fourth, right? I started with x to the fifth. 2x to the fourth plus x cubed minus 3x squared minus x plus 1. Is that making sense where I'm getting that from? You can see the two, I'm getting coefficients of what's called my depressed equation. Depressed meaning it was a power of x to the fifth. It was a power of x to the fifth, right? But I divided by x, so now it's a power of x to the fourth, right? Now, f of x is x minus 1 times that 2x to the fourth plus x cubed minus 3x squared minus x plus 1. And we rinse and repeat, but we do that with the depressed equation. Does that make sense? We use that quotient to check if 1 goes in again, right? So we're going to take 1 into that new piece, 2, 1, negative 3, negative 1, and 1. Is that making sense to everybody? So I take the coefficients of my depressed equations and synthetic divide again. Remember, I saw the original function. I knew 1 was a 0 with a multiplicity of 2. So it means I can synthetic divide the original and the depressed by 1, and I should get a factor, right? Is this okay? Everybody with me? So bring down the 2, multiply, add, multiply, add, multiply, add, multiply, add. Perfect. Since x equals 1 is a 0 again, x minus 1 is a factor, and so is 2x cubed plus 3x squared minus minus 1. Right? I could write 0x, but why? Right? Now, f of x is x minus 1 times x minus 1 times 2x cubed plus 3x squared minus 1. Right? So we're kind of just chipping away at this thing, right? Is that making sense? Chipping away at it by synthetic to get it completely factored. And you'll see these factors that I'm getting in calculus are going to be called, we call them critical values, because they're going to tell us where certain things are changing either at extreme or a very slow rate. And we want to know, in most of our professions, we want to know how things are changing. And this is what study of calculus is. It was really originally about, hey, when's the moon going to be here again? Right? So you got the Earth moving around the sun, rotating on its own axis, right? And the moon moving around the Earth and its own axis. And so Newton was trying to figure out where the planets will be at any time, right? So I go back to my original equation, and I see that what are my other roots? I've got a negative 1, and I have a 1/2. Do you see that? I got a root of negative 1 repeated twice, and I have a root of 1/2. I personally would rather deal with the root of negative 1 than the 1/2, right? It's not that I hate fractions. I'm just happy when they go away. Same with family, though, right? I don't hate my family, but when they leave, it's better. I don't know if you feel that way. So we're going to synthetic divide. So x equals minus 1 is a repeated root as well. So negative 1 into my depressed 2, 3, 0, minus 1, right? I need that placeholder again, though, right? You with me there? Be careful of that placeholder. When I write it, I don't want to include it. But when I synthetic divide, I have to, right? So I get 2, a negative 2, a 1, a negative 1, a negative 1, a 1, a 0. Nice. So x plus 1 is a factor. And f of x is now x minus 1 to the second power times x plus 1 times my, 2x squared plus x minus 1. Right? You with me here? Is everybody okay? You gotta give me some kind of grunt or symbol. Yes, Eli. Exactly. So repeat it an even number of times if it bounces. Repeat it possibly an odd number of times if it goes through. if you look at how this particular function is going through, if you get really close to where it's getting through, it almost looks like a straight line. So that's hinting at x to the first power. If I threw it on as a third power, it would look like it's going through like a cubic, right? So like if I just do y equals x minus 1/2, you can see, oops, you can kind of see that the blue line is covering the red line for a little bit. So it looks almost like a straight line there. But if I go to y equals x minus 1/2, and then I raise it to the third power, it's still going through, but you see the curvature of an x cubed function. You with me there? So we can synthetic again by -1, right? With this 2, 1, and -1. Or once I get to a quadratic, you can go back to middle school and factor the way you learned in middle school. I don't care. You don't have to. I think synthetic division is quicker than split the middle term, but it's up to you. Okay. So let's see. Looks like we're done. F of x is x minus 1/2 squared, and then I got an x plus 1/2 squared, and then I got a 2x minus 1. And the only thing, if you remember, right? If you remember, we kind of want to write f of x with that leading coefficient of a, right? Of some number a. Does anybody see what it is? Yeah, it's 2. So I'm going to take that 2 out of here, right? And then what does that factor become? And it's really easy. You don't have to overthink it because you can already see what factor it is. It's got a 0 of 1/2, right? So it's x minus 1/2, right? Is that making sense? And of course, if you see me distribute that 2 back in, the x becomes a 2x, the 1/2 becomes a 1, right? If I distribute that 2 back into that one factor. So there's the first question on your next quiz, right? Making sense? I'm going to say factor this polynomial. And yes, I'd like some of the writing. If you can give me some of that explanation, that would be good. When Cooney's not here, Hassan's not here. Jason's here. John's not here. Emmanuel's here. Savon, I have your test. Who else didn't get their test back? Savon. Rafi's not here. Brian, I have your test. You guys want to grab it? You saw my solutions up there, right? Sorry. Brian. Yep. Savon. Francisco? Yep. Test solutions are on there. Look it over. Talk to me about it. All right, all you guys. So look over my solutions. Make sure you understand what happened. I reminding you, there's 8 pages of questions. So this was test 1. So there's 13 points per page. That's 104. And I gave you 1 point for signing your name. I gave you 1 point. No, I gave you 2 for signing your name. So if you take the numbers on the bottom right corner and subtract them from 106, that should be the number on your front page, right? And I make mistakes, so just look it over. Meet with me. Come early to class. Stay after class. I don't care. Johansi's here. Ivan is here. Sina's not here, huh? Jose is here. Chris is sick. Rafi's not here. Okay. Not bad for 4-1 and 4-2, right? That's the main thing I want you to be able to do. So let's recap 4-4. I've got a rational function of 2x squared minus 7x plus 3 divided by x squared minus 9. And so this is the standard form, right? This is standard form. We'd like to be able to write it in factored form and possibly reduced form as well. The downstairs function here I can see quickly, x plus 3, x minus 3, right? If you need to go back and review how to factor quadratics, please do so, right? Certainly I could graph that downstairs. And see that I'm hitting roots of 3 and minus 3 and synthetic divide, right? So I can use this synthetic division to sure up my factoring from algebra 2, whenever that was, okay? I'm going to do the same with the numerator, right? What was that? 2x squared minus 7x plus 3. And notice I hit a 0 of 3. Do you see it? I hit a 0 of 3 there, right? So instead of me factoring splitting the middle term, and I'll do that if you want to see it again, but I'm going to synthetic divide here, right? So I'm doing a little side work with a 3, with a 2, a negative 7, and a 3. Yes, you with me? Everybody okay here? Yep. So I bring down the first, I multiply, I add, I multiply, I add. Nice. So I got a factor of x minus 3 and a factor of 2x minus 1. Does anybody want to see the split the middle term like you were taught in 8th grade or 9th grade, or for me it was 11th grade because I failed it twice? Does anybody want to see me split the middle term? You want to see the split the middle term? So we taught you this AC method, right? We said ax squared plus bx plus c, right? And we're finding factors of AC, which is what, 6? So 1 and 6, 2 and 3. And I want them to add to negative 7. So I need negative negatives, right? You with me there? CD, yeah? So I take the values of A and C, I multiply them together. I got a 6. So I know the factors. I need a 1 and a 6 or a 2 and a 3, right? But I want them to multiply to positive and add to negative. They both have to be negative. So I get what? I get 2x squared minus 7x plus 3 becomes 2x squared minus 2x minus 3x plus 3. I split them. It's called split the middle term. You remember that at all? Yeah. So then I group. I could take out a 2x here. I could take out a negative 3 in the second piece. And I see a repeated factor of, uh-oh, what did I do wrong? Oh, I used the wrong, I need a negative 7, right? I need these two. Sorry. So I'm gonna use minus 1x and minus 6x there to split that middle. I can see I get a factor of x. I've got a factor of negative 3. So I have a repeated factor of 2x minus 1 and a leftover factor of, what's the leftover? X minus 3. So obviously synthetic is faster, right? Yes, but I'm telling you, we're cheating. I'm going to say, look at the graph. Look at the graph. So you're absolutely right. But even if we were just using our dinosaur calculators, we could see where the 0 was, right? I'm taking out all of these theoretical pieces that will take up a lot of time when you're in calculus. I don't care if you know it theoretically. I just want you to be able to factor. And that's what I'm trying to do. I'm trying to be able to get you to be good machines so that I can add on new information, new intelligence to you in Calc 1. So I've got my standard form, right? I've got my factored form. If possible, I want my reduced form, and you can see that as 2x minus 1 over x plus 3. How are we doing? What do all three of them look like? They're all identical. If I graphed all three of them in Desmos, all three graphs would match. But there's a secret here. I have to be careful of the domain. What's the domain? Except for and we're going to get this from factored form, right? What's my domain? I can't divide by 0, so x can't be plus or minus. Look at the factored form. I can't divide by 0. Plus or minus 3. I can't have that. And I'm saying that is also true in my reduced form, right? So what do I know? X equals 3 is a vertical asymptote. Sorry, x equals, x equals, negative 3 is a vertical asymptote, right? I'm looking at this, I'm saying, what makes that 0? Hey, John. Right? So x equals minus 3 is a vertical asymptote. Yes? I recorded everything, John. And x equal 3 is a what? A hole. If I plug in 3 to my reduced form, I find out where the hole is. So what is it? 6 minus 1 over 6. So at 5, 6, there's a hole at 5 over 6. That height. So at this point, I probably want to graph. Since it doesn't matter which one I graph, and make sure you prove that to yourself, I'm going to graph my reduced form. So 2x minus 1 over x plus 3. And I want to plot that information I know already. I know x equals negative 3, which I'll dash, is my vertical asymptote. And 3 comma 5 over 6, which I will hollow out, is the hole in the graph. How are we doing? Yes? Question, Eli? Yeah, I'm trying to make things look pretty for you also, so you don't have these. The book is not good at it. They just have sometimes random things. I'm going to try and make sure I can give you one problem that will show you that you could show me you know how to do everything. Good. What else can we find on this curve? What else do we know about this particular curve? How about y-intercept? That's when x is 0, right? So what do I get? 3 over negative 9, negative 1/3. Is that agreeable to everybody? I'm just putting in the 0 for x's, and it's easier for me to do that in the standard form. Right? Do you agree? I want to go right away and see if that makes sense here. Do I get a 0, comma, negative 1/3? Oops. Yeah, right? And I don't hollow that one out because it's actually on the curve, right? Does that make sense? I want to do x-intercepts. That one's going to come from my factored form or my reduced form. And I want f of x to be equal to 0, right? Which means numerator equals 0. Which means 2x minus 1 equals 0. Which means x is 1/2, right? Everybody with me there? Say again? Yes. So to find my x-intercepts, I want to go to my reduced form, right? I know where things cancel, there's a hole, and I already took care of that. I found out where the hole was, right? So I go to my reduced form, and I set the numerator equal to 0. And of course, if it's factored, it's very easy. So I've got my x-intercept. Yes, Eli, yeah? So I want to put that in. So I had the x value of 1/2, and I had a y value of 0, obviously. And I'm just confirming, right, on my curve that I'm hitting that point where it hits the x-axis and the point where it hits the y-axis. One more thing to do. I got the vertical asymptote. I also want horizontal asymptotes. I know there's no oblique here, right? How do I know there's no oblique asymptote? The numerator mother function would be what? It'd be a higher power than the denominator mother function. When the numerator mother function is a higher power than the denominator's mother function, it's, well, if it's 1 degree higher, it's an oblique. If it's 2 degrees higher, it's parabolic. If it's 3 degrees higher, it's cubic, etc. Right? So who's got the horizontal asymptote here for me? So it's saying, well, my function looks like 2x minus 1 over x plus 3, which implies the function looks just like the mother over the mother as x goes to plus or minus infinity, as you go out real wide, right? And so so that means the horizontal asymptote is y equals 2. Yes, you with me? So y equals 2, and again, I'd like that one to be dashed, but maybe long dashes. So there it is. That's what I want you to be able to do on the second quiz question on Wednesday, a week from today. And you'll give me a rough sketch. Why is it that I'm doing my vertical asymptote in this tiny dashes? Because the function can never cross a vertical asymptote, okay? Why is it that I'm using long dashes for the horizontal? Because it can. I'm trying to, I don't know, put a warning in there. I don't know. It's not like passing lanes and things like that, but it's just me trying to be a super nerd. Can you tell here that I never cross the asymptote? Can you see that? So certain functions will. This one does not. So yeah, it gets really, and that's what the horizontal asymptote is. It's almost like what the function becomes in the long run. It never quite gets there, but right. So I guess the interesting other problem to do, which I'm not going to quiz you on, would be to look at the function greater than or equal to 1 or 2. That would be the interesting question there. F of x is greater than or equal to 2. I want to see if it ever hits the asymptote by asking this question, right? So what would that mean? I would need a 2x minus 1 over x plus 3 greater than or equal to 2. And I did a problem like that last class. But I'm not going to review it because it's not on the quiz. Unlikely on the test. I don't care too much about that in calculus. That's why. I'm trying to do the things and test you on things that I care about in calculus. Okay? All right. Ready to go. Ready for new stuff? Break first or go right into it? If you need a break right now, just go take it, right? I'm recording. But I will take a little break in about 15 minutes or so, okay? Go ahead. You got time. All right, here we go. Chapter 5. We're halfway through the semester. It's really a 14-week semester, but Thanksgiving week I count as a 15th week, and the final exams I count as a 16th week. So we're in our 8th week. We started late, so we're really in our 6th, but it's halfway for the whole semester. So we're doing okay. I'm a little bit worried about you practicing more, but in terms of me getting through the material, I'm easily on track to getting through, right? So, but you gotta keep doing work every day. I mean, it's the reason why I'm really good at watching TV. I do it every day. I mean, I know all the channels and everything, right? So, but you gotta practice. Music, sports, mathematics, they're all similar in that you have to practice every day. So chapter 5 is about inverse functions. Logarithmic functions, log functions, and exponential functions. This is really 5.1 to 5.2, and this is 5.3, and I think I'm going up to 3, 4, 5, 6, up to 5.6. So for sure, we're gonna get to all of our inverse functions today. The first thing I have to talk about is composition of functions. Okay. And if I start going too fast, just slow me down or ask me to go back a screen, right? So 5.1, we're first talking about composition of functions. Did I tell you that news about Beethoven? Did I tell you news about Beethoven? Did you hear this on the news? They think he was buried with some pieces of music that no one ever heard, so they dug up the gravesite, and he's sitting there, he's erasing. And they said, "What are you doing?" He says, "I'm decomposing." That's not funny. It's funny. The guy's dead, first of all. You think he's going to talk? Yet alone erase? So what I'm talking about here is putting a function inside a function. So we're talking about notation-wise. right, let f of x and g of x be functions, h of x is f composed of g of x. It looks like fog, but the easier way to think of this composition is f composed of g of x. So I want you to see, and oftentimes students get confused with this piece because they think you're multiplying by x, but that's the input. But it's a lot easier to see that the input, I'm putting function g inside of function f. Have we done this already anywhere? Say yes. Good, where? Exactly. We put x plus h inside the function, right? So that was a composition of functions we already did, right? So what has to happen here is we need to think about the domain of this, okay? So the domain is a little tricky because I have to first think about the domain of both of my functions, right? And then think about which g value is going to screw up the function f. So I have to kind of think of the domain of g, the range of g that will get me in trouble in f, and the overall, once I make my new function, the overall domain of that. And I'll show you what I mean. It makes it easier if I show, okay? So let's say f of x is 1 over x, and g of x is x minus 2. What's the issue with my domain for g? What's the domain for g? Exactly. So it's oh no, g is there anything, right? I can plug a 2 in there, right? 2 minus 2 is 0, that's fine, right? So, but what's the issue for f? The domain of f, x cannot be 0. So then I'm asking, what g value gets me in trouble? What g value will give me 0 is 2, right? So if we look at h of x, right? It's 1 over x, but what am I putting in for x? I'm putting in the function g, right? It's the composition of functions. Let me write it again, like this. F of g of x. That's what I want you to think about. That's my notation, or the book will use it sometimes, but they like to use the other notation, which I think is confusing. So this is saying the outside function is f, right? What's that? 1 over x, yes? But what am I putting in for x? I'm putting in g. Okay, but I know g of x, right? It's x minus 2. So if you can see this, I have to think about the original domain of g, the piece of g that will get me in trouble with f, and then I also have to go back to this and now say what's the domain of h. X does not equal 2, right? All right, let's do another. Yes? So let's look at f of x as something like x over 3 minus x. And g is x minus 1 over x plus 2. let's think of the domain of G. X should not equal what number? -2. Over here, I'm worried about x equal 3, right? But I'm really more interested in where does g of x equal 3? Right? So kind of look at this connection here. I want g of x equal to 3 because that's going to be trouble. Right? So I'm looking at 3 equals x minus 1 over x plus 2. I cross multiply. Don't let me go too fast here. I'm going to solve for x. I want to cross multiply, yes? What do I get? 3 times x plus 2 should equal x minus 1. Is that okay with everyone? Cross multiplying, yes? I get 3x plus 6 equals x minus 1. I get 2x equals -7, or x equals -7 halves.
How did you get it from being a fraction to like
I cross multiply. Yeah, so cross multiply is like New Year's Eve. What do you say when you have a drink? Cheers. What else? Fine. If you're Polish, Nostrovia, or Russian. If you're Jewish, L'chaim, right? I also say bottoms up because you can see the bottoms of the glass. So that's what I did. I cross multiplied up, bottoms up. Yeah. So I subtracted x on both sides to get 2x, and I subtracted 6 on both sides to get -7. So I'm worried about 3 now. I'm not only worried about -2, I'm also worried about 3. Right? You with me? Okay. So let's put that thought on hold for a second and let's do our composition. So h of x is now f of x composed with g of x, meaning I'm going to write f of x, and watch how I do this, please. F of x is x over what? 3 minus x. Right? You see it? X over 3 minus x. You see it? Empty parens. And what am I putting in there? I'm putting in my function g. Yes? This is f composed of g, meaning everywhere there's an x, a placeholder for x, in my outside function, function f, I'm putting in that function g. Does that make sense? All right, this is kind of nasty now. So this is x minus 1 over x plus 2, and then I have 3 minus x minus 1 over x plus 2. You can still see that putting in a -2 is wrong here, right? You agree with me? But putting in a -7 halves is also bad, because -7 halves is going to turn my function g into the number 3. And then I'll have a 3 minus 3 downstairs. Make sure you see that with me. Okay, I like to clear fractions. I want you to learn how to do this, damn it. Don't cheat it. Don't try and shortcut it. Learn how to do this, because you'll suffer through Calc 1 if you don't learn how to do this. I'm trying to find the interior denominators and the LCD of the interior denominators. This one is pretty darn easy. There's only an interior denominator of x plus 2, and 1. I am not looking at the overall denominator. I'm looking at the denominators within the fractions within the fraction. So I know x plus 2 is going to clear fractions for me, but I can only multiply by 1. So I'm multiplying everything upstairs by x plus 2, everything downstairs by x plus 2. I'm going to try and take my time here and not rush through this, meaning I'm going to write the original function in black and the new function in green, this new multiplier in green. I'm trying to take my time. I don't care if you skip this step when you're good. When you know you're not going to make a mistake, right? You've done several of them and you're like, oh, I'm tired of doing that. I don't care if you skip it if you're not making mistakes. If you skip it and make a mistake, yep. I like to change my color to the color of blood and cancel. And rewrite, not in a hurry. I'm not in a hurry. I now just have x minus 1 upstairs, and I have 3 times x plus 2 minus x minus 1 downstairs. I am not in a hurry. Yes, you with me? I'm trying to do baby steps. Eli. Correct, to the numerators of every term in the numerator and the numerators of every term in the denominator, yes. I don't know if you could see it already, what's happening downstairs. But now I have an x minus 1 upstairs. I have a 3x plus 6 minus x plus 1. Oh, guess what? I get a 2x plus 7. Recognize the issue with the domain now. So my domain, yeah, Godzilla. The domain of H is x not equal to negative 2 and x not equal to negative 7/2. Remember, I have to take that domain issue from my original functions. All right, let's take a little break. Let's take 5 minutes now, okay? Find the function. Sorry, I have to find the composition of functions, but then I want to test that my composition worked, okay? So, a double check of the composition. So for example, if I take those two functions I just had, I had x over 3 minus x, right? I had g of x, don't tell me. X minus 1 over x plus 2. All right, I want to just take a quick look at what happens if I put in, let's just say g of 2. So I'm picking something in the domain, anything I want, okay? I'm picking anything I want in the domain. You with me? I'm picking, let me make it easier on us. Let me pick minus 1. So I'm going to pick negative 1. What's the only number I can't pick for g? Negative 2. That's not in the domain. So anything I want. And this is why I like math. I can pretend I'm God. Let there be zebras, right? Let there be x is negative 1. I can do anything I want here, right? So, and I swear to God, I'm an atheist. Get it? Swear to God, you get it? You can't swear to God if you're an atheist, right? Okay, so I put in my -1, and what do I get? I get -2 over 1, so I get -2. Yes, you with me? I want to see what happens if I put in -2 to f. So I get -2 over 3 minus a -2. I get -2 over 5. Why am I doing that? You'll see in a second. But remember, g is the inside function in my composition, so I have to start there. What comes out of g then goes into f, right? So now, what was my composition I just did? What was h of x? X minus 1 over 2x plus 7. Because now, what am I going to put into h? I'm going to put in -1, right? Because that's how, remember, that's where I started. I started by putting a number into g. What came out of g, I put that into f. Now I'm just putting this -1 into h. What's going to happen? What am I going to get? Do you know? The answer's on the screen already. Okay, fine. So -1 over 2 times -1 plus 7. So that's -2 over 5. Ha! What do you know? Right? You see what's happening? So this new composition function takes the whole process I did with the two functions and made it into one. Right? That's why we're coming up with these compositions. So looking at the textbook, I'm going to just pick a problem from so Emmanuel, the first problem I did was from 23 to 37. The second problem I did was from 13 to 21. Okay? But they're in my do the suggested, right? And so you see how they kind of have them grouped into sections. Hey, Sina, the food's down there. If you need to go do that first. Oh, good. So you see how 13 to 22 is one section of work. So if you get stuck there, it doesn't mean just quit. It means maybe try the other section, right? But you'll see that they're giving me two functions, right? And they want me to find, the first one says find the composition of 4. That's h of 4, right? But what do I want you to do? Put 4 into g. What comes out of g, put into f, and see if they match. And they will. You did it. This next one was the domain one. Right? And finally, 39 to 46 here, this is our last section of problems in this section. And it turns out, so I'm going to do 38, okay? Because I think you like those clearing fraction problems. I'm being sarcastic, of course. I'm going to take a look at these two functions. These two functions have a certain property, okay? So this is 5.1, number 38. And I've got to, yeah, question. It's, yeah, composed of. F composed of G. That fog, I call it fog. That notation I don't like. Most students get confused with it. So instead of writing F composed of G of X, I like F, just, you can clearly see what the inside function is, it's g of x and putting it inside of x, f, right? So this one is, I think, a lot clearer, but the book will often write this. Right, so if they gave me f composed of g of 4, oops, sorry. Right, that's the same as f of g of 4. That's the easier way to think of it. Right? So let's pretend g of 4 is some number like 7. You'll see that this now will become f of 7. Right, you see that? Put the 4 into the function g, put the result into the function f. Should be the same as putting 4 into h. Right, the composition that I created. Okay, let me start over. 5.1, number 38. So they gave me two functions here. F of x is 2x minus 1 over x minus 2. And g of x is x plus 4 over 2x minus 5. I want to notice something about these two functions, and they're special. They have a special relationship to each other, and there's infinite number of these relationships. So don't think these two are special. Okay, but what I want to do is I want to graph the two of them. Oftentimes, once I get things in Desmos kind of all stretched out, I'll just start a new window. If I don't like the scaling that I've created by moving things, I'll just open a brand new window in Desmos. So I'm going to use f of x, right? And my f of x was 2x minus 1 over x minus 2. And I want to also graph g of x, which I said was x plus 4 divided by 2x minus 5. And I'm going to graph the line y equals x. And I'm going to dash that. What do you notice? I'm a pretty loud dresser sometimes. You hear me in the morning. I'm putting my shirt on. No. Yeah, I'm asking, do you notice anything? Let me make sure I didn't say something wrong. It should be a little bit clearer than this. Oh, sorry. I did the wrong one. Damn it. I'm sorry. So you shouldn't have noticed anything. Let me do a different one. Oh, I don't like any of these. They all suck. Let me do 44. Sorry. All right, so I have two functions, f of x equal to 4 minus 3x, and g of x equal to 4 minus x over 3. Sorry, this one will make a little bit, it'll make more sense here. So, four minus 3x, g of x, 4 minus x all over 3. All right, now it makes more sense. Look at the left side of y equals x and the right side of y equals x. What do you see? You see any symmetry? No, there's symmetry. They're symmetrical about the line y equals x. Right? So if I take this side and fold it on the line y equals x, they match. So the black function on this side is mirrored by the purple function here, right? The purple function here is mirrored by the black function over there. You see the fold at least?
Oh, I can see it now.
Okay, so these are called inverse functions. They undo each other. So imagine having a car that you can only drive forward. It would be a disaster, right? If you parked it front end to somewhere, you'd never get out, right? Well, you can push it back, you know. But so we have to learn to undo things. So notice what happens. Oh, who wants to play God here? Give me a number for function f. Sure, 7. So f of, let's start with g. Sorry, you want to still use 7? That's fine. I like it. 7 is a perfect choice, by the way. G of 7 is 4 minus 7 over 3. That's negative 3 over 3. That's negative 1. Agreed? Now I'm going to take, question, Jose? What, say again? It's still recording. Yeah, it's still recording. Oh, it's, sorry. 596. Now watch what happens when I take that result and put it into f. What do I get? 4 minus a 3 times a negative 1. That's 4 plus 3, that's 7. Do you see the input and output switched? And this is the same as y equals x. Y equals x and x equals y. They switch. They're the same. Y equals x or x equals y, it's the same. So when I get inverse functions, I'm switching my inputs and my outputs. No, that's a great point. Watch what happens when I find f composed of g. Watch what happens when I find f composed of g. What is f? 4 minus 3 times x, but I'm not putting x in there. I'm putting an empty set of parens because what am I going to put in there? What am I going to put in there, g? Yes, g, right? So 4 minus x over 3. Yes, I'm putting g into the function f. What happens? Look at what happens. The 3's cancel here. So I get 4 minus x. You get 4 minus 4 plus x. I just get x. When I compose inverse functions with each other, everything falls apart, and all I get is the x. Let's do j of x as g composed of f. What is my function g? 4 minus x all over 3, but I'm going to put in there my function f, which is 4 minus 3x. Everybody with me? Don't let me go too fast here. When I have this composition, when I have inverse functions, I have to be able to check both compositions, and both compositions should give me the same result. I can have a function that only has to inverse one way. I need the inverse to work both ways. I need f composed of g and p composed of f to be the same result. So what do we get here when we do this one? So I get 4 minus 4 plus 3x all over 3. So I get 3x over 3, so I get x. When I compose inverse functions with each other, both ways, f of g, g of f, I should get the same result, x. Question? It's possible for it to work only one way. So, for example, x squared is the square root of x. Right? It's hard to think about it, but if I say 2 squared, I get 4. If I take negative 2 squared, I get 4. So when I come back to the inverse function, I put in 4, but what comes out? Not plus or minus 2. It's only 2. If I square root of 4, I only get a 2. But when I squared it, and I'll talk about that function later. But Jorge, are you hearing what I'm saying now? Yes. It's weird. It's pretty damn rare that I would have one that would work one way and not the other. And we'll try and avoid that. All right, here we go. Next section. Ready? 5.2. Inverse functions. So, when will a function have an inverse? How do you find an inverse function? How do you prove functions are inverses? These are the 3 questions we want to answer in this section. I don't think I'm going to get to section 5.3, but that's fine. I can do that next week. You could leave that section on for homework because I'll teach it Monday, and your homework's not due the following Monday, right? Yeah. When does the function inverse exist is the first question. How do you find the inverse is the second. How do you prove that they're inverses is the third and fourth. Okay? Because I'm going to show you 2 ways to prove. Okay? And so I'm not going to have you do a simple composition of functions on a quiz or on a test because that process is in these questions and the solutions to these questions. So I need you to practice composing functions. That's 5.1. But I'm not going to quiz on it. I'm not going to test on it because it happens again in 5.2. Okay? Yeah. So when does the inverse exist? Exactly. So first of all, let f of x be a function. For example, x cubed, right? Remember what I need for a function. I need it to pass the vertical line test, right? I need to make sure for each individual x, there's one and only one y. Yes? You with me? If g of x, which is f to the f inverse of x, that's not f raised to the negative power, it's f the inverse of f. So f inverse or the inverse of f, you could say it, right? But I don't want to say f inverse. I want to say g of x is equal to the inverse, and then use g from now on, okay? if g of x, which is the inverse of x, exists, then f must pass the horizontal line test. So if the function is, I'm starting with the function, it passes the vertical line test, right? For any x, there's one and only one y, right? Yes, you with me there? Just lie to me and say yes. Yeah. So I draw a vertical line, right? Every time I hit the x-axis, I better hit the height once. If it passes the horizontal line test, I'm saying almost the opposite. For every y, there can be only one x. So anytime I hit a y value, I better only hit it once. Only hit it once. If I hit more than one y, then both they would have different x's. For every y, there's one and only one x. Exactly. No repeated y values. That's the key. If I have a function that has no repeated heights, then I know the function is 1-to-1. So if the function f is 1-to-1, which means for every x there's one and only one y, for every y there's one and only one x. Or better yet, it's a function and there's no repeated y values. That's the easiest way to think of it.
So here's my question.
Yep.
So if you have an x that has more than one y value, the same y value, what do you consider one-to-one with it?
Correct. So it's as easy as this. It's as easy as this. Graph the function. Look for repeated height. Right? Look for repeated height. If you have repeated height, no good. I cannot do it. So for example, x squared is a function, right?
Yeah.
So y equals x squared is a function. Right? So take a look at y equals x squared, right? No problem. We know it's a function, right? But look at the horizontal line test. It's not 1-to-1, but y equals x squared is not 1-to-1. So, Jorge, I'm going back to what you were talking about before. If I put in a -2, what do I get for the height? 4. If I put in a +2, what do I get for the height? 4. So now I'm saying f of -2 is 4, and f of 2 is 4. When I put in the inverse, when I put into the inverse of 4, right? Remember, it's supposed to come back to what I started with. Which one do I pick? See, that's the problem. That's the problem. And so remember we talking about the function in terms of soda machine? I hit the button, I put money in, I hit the button, and it soda out. Put money in, hit the button, it soda out. Put money in, hit the button, and live chicken. Remember that? It's broken. So here, see, I have more than one output. It could be 2 or -2. Which one? Do I get the soda or do I get the chicken? That's the problem. It's not clearly defined. It's not a function. It's not a function. There's 2 options. Which one am I going to get? Right? Is the car going to start or not start? Okay. So, how do I find the inverse? Is that my second question? Yeah, second question. How do you find the inverse? It's pretty simple, but some of you will fight me on it. Don't fight me on it. You can't win. I'm very stubborn. Ask my ex-wife. Okay? You will not win on this. You have to practice. You have to be able to do it. If I put a difference quotient on this next test and you still can't do it, I'm going to scream. I won't scream. I don't care.
Is it a record?
I don't care if you can do it or not. But if you can't do it, why? Ask for some damn help. Please. I'm not teaching when I'm lecturing. I'm just showing you what you should be able to do. When you need help, that's when I get to teach. That's when I get to figure out why you can't do something. Ask for help. How do you find the inverse? Here we go. So first thing we're going to do is verify it's 1-to-1. I have to show you that, but right now you're just going to graph it. Okay? We can do an example right away. So we actually know how to graph this without the calculator, right? Where's my vertical asymptote? Where's my horizontal asymptote? Yeah. In the short run, this looks like 2/1 divided by x minus 1. Remember, plug in 1 where it works, not where it fails. So I get 2/x minus 1. That really looks like what function? What mother function does that look like? Nope, 2/x. So I want to see that 1/x shape happening here. If you don't like that, and I wouldn't blame you, you go to Desmos, right? What did I have? 2x over x minus 1, right? Right? Do you see the 1/x shape? Yes or no? You see the 1/x shape? And it's stretched out a little bit. It's 2/x, right? But it's shifted over, right? 1 to the right. And stretched by 2. Yes? Is it 1-to-1?
Is it 1-to-1?
Look at it. Is it past the horizontal line test? Here, I'll help. I'll put in y equals 2 for my my horizontal and x equals 1 for my vertical, right? Is there ever a repeated height? No. So it's 1-to-1. Step 2, replace f of x for y. Step 3, solve for x. Step 4, replace x and y. Step 5, rewrite y equals f inverse, or g. Do the compositions. Better yet, do a numerical check. do the compositions. And you can see it's a pretty hardy problem here. So this is what's on the next quiz, right? But you have time to practice, right? So you have time to practice this week and then ask me about any one of the ones in the book on Monday. Or send it to me via email. When you send me a problem via email, I want to see the problem, I want to see your work, and then add some kind of comment. Not sure why I'm not getting this, right? Maybe I'll say, oh, you just missed a negative here. Or I'll say, I'll do it in class. Okay. Yes, ready.
So you always have to do the vertical test to find out if it's 1-to-1? As long as with the
Horizontal test.
So not a vertical.
Vertical is just if it's a function, right?
Okay.
Right. But I'm not gonna give you a non-function. I can't. There's issues, right? I'm not gonna give you a soda machine that could give you a Coke or a live chicken, right? Because I don't want to clean up the inside of the machine, right? So, so let's go with this one. This is not an easy one, but let's start with this one because I think you can handle it. Okay, so we have f of x is 2x over x minus 1. I want to find g of x, which is the inverse. But I'm going to call it g because I'm lazy. I know what I find is the inverse, but I'm going to call it g. Okay, just because I want to. Because the notation is confusing. How to say it is confusing. But I know I'm going to find the inverse. Step 1, let f of x be y. I'm going to solve for x, and I start by toasting bottoms up. So I cross multiply, right? You with me? I'm going to distribute. This process is pretty much the same every time, but if you don't have fractions, you don't need to cross multiply, right? So, but you have to think about what you're doing to solve for x. I want to isolate my x terms with a minimum number of negatives. If you don't, you'll still get the right answer, but you'll just have to do some extra factoring. I'm trying to keep it as clean as possible. If I don't have to say negative, I don't want to. So meaning, what did I move here? Do you see what I moved? You see what I moved? I moved the y to the right, became positive. I moved the 2x to the left, it became negative. Couldn't I have just moved the xy and it becomes negative? But how many negative signs do I have now? I have 2. I want to reduce the number of negative signs. Again, it will still work if you do this instead, but I'm telling you, it will make your life a little bit easier. We okay? I'm going to factor out my x. And then divide. How are we doing? I'm switching all my y's become x's, all my x's become y's. Remember this reflection about the line y equals x. y equals x, x equals y. I'm switching inputs and outputs. So I get y equals x over x minus 2. May as well switch. So I get g of x, which is f inverse of x, is x over x minus 2. I want to add something to my list. Yeah, so all x terms on one side. I'm adding a graphical check, right? Do a numerical check, do a graphical check, once you get your inverse. So let's do our graphical check first. What's the domain of f? Can you tell me? It's domain. What's the domain of f? Everything but 1, right? What's the range of f? Or what's better yet? What's the horizontal asymptote? 2. What's the domain of g? Everything but 2. What's the horizontal asymptote of g? 1. Okay, which? Okay, we'll bring that point back up later. Let's put these in Desmos. Yeah.
So the reason, okay, so why did you have to factor once you isolated them? Why did you factor?
Well, if you notice, once I factored, if I divide by this, I get x by itself, and that's what I'm trying to do. And pretty much you'll have to factor in almost every problem.
Okay.
Yep. So let me put these into Desmos with my line y equals x, right? So this is f of x. And g of x. I think I got x over x minus 2, right? And then I'm putting in the line y equals x. And again, we're just looking for the mirror image. Right? The mirror image, yes. Mirror image, mirror image. I'm going to do my numeric check. Let's say g of 1. So let me not do 1. Let me do I don't like 7 this time. Let me do 4. So 4 comma g of 4. I'm just trying to have it come out kind of nice. And then what's the result of g of 4? Is it 2? Yep, 2. And then 2 comma f of 2. And I'm going to do this on paper in a second, so don't freak out about it. But if you see the x's and y's switch here, right? You see it? The x's and y's switch, right? This is what? 4 comma 2, right? And this is 2 comma 4. Yes, you agree with me there? X and y switch on inverses. So I'm checking graphically, got it. See, I see the symmetry. I'm checking numerically. I didn't do that yet, right? Let me do that. So numerically, I'm checking. Why won't my pen work? Here we go. Here's my numeric check. Ah, my pen's not working. Damn it. What happened? No, I must have walked away with the pen. Let's see if I can do it. F of 2 is 4 over 1, right? You agree?
Yeah.
And then G of 4 is 4 over 2. So they switch, right? You agree?
F of 2. I just put 2 in. 2 times 2 over 2 minus 1 is 4 over 1 is 4. Now I'm going to take the output and put it in the inverse. So 4 into G. So 4 over 4 minus 2. That's 4 over 2. That's 2. So input and output switch.
What's the last thing I should do? Compose them. I'm going to compose them. I got to go old school. I lost my pen.